Okay, we're going to do a Newton's method tomorrow, and we're not going to do a ton of these, but I want you to just at least be up to date on the concepts anyway. Not to mention the fact that it practices making equations of tangent lines and coming up with the equation of tangent lines, and that's a good skill. So first of all, let's start off by saying if we have a point and a slope, we are going to, well, I guess let's look up here first. If we want to find the x-intercept of this particular linear equation, we set y equal to 0. And if we set y equal to 0 and we solve for x, what we find is we find the place where the where the graph crosses the x-axis. So in this case, again, set y equal to 0, and this, what you'll find is x is equals 3/2 is where this thing crosses the x-axis. So that's finding an x-intercept. Second thing, if we have a point, -1, 4, and a slope equal to 2, then point slope form is y minus 4 is equal to 2 times x plus 1. This is x plus 1 because it's x minus a minus 1, which would happen up here. Okay, let's look down at Newton's method. So we're going to use both of these things to approximate zeros of functions by tangent line intercepts. Okay, so if we don't know what one of the roots or what one of the x-intercepts of the functions, we guesstimate. And after we guesstimate, we can use Newton's method to get better and better guesses subsequently. So dealing with this equation, y equals 2x to the cubed minus 3. Dealing with that equation, we know that there's a root somewhere between 1 and 2. If 1 maps to -1 and 2 maps all the way up here to 13, then somewhere between the two there must be a crossing, so there must be an x-intercept. So the first thing I'm going to do is I'm going to put a good guess together. And my first good guess is 1.2. I said that's a lot closer to 1 than it is to 2, so I'm going with it. So what do? Well, first of all, we got to find a point. So we plug 1.2 into the original equation. Once we do that, we find out that the y value is 0.456. The second thing we do is find the derivative, and then we plug 1.2 into the derivative. This is 8.64. This gives us the slope. So with the point and the slope, we can come up with the equation of the tangent line. That's y minus 4.56 equals 8.64 times x minus 1.2, which was our x value. Now that we've got the equation of the tangent line, we can set y equal to 0. We don't have to solve this thing for anything. We just go ahead and set y equal to 0. So basically, negative 0.456 equals 8.64x minus 10.368. This is just this distributed over the 1.2. I do a two-step equation. I found out that x is actually closer to 1.147, and this would be my next guess that I'm doing. In the book, they might have you do a couple of iterations, which means repetitions, but that's your basic concepts. We plug the guess into the original function and find the point. We plug our guess into the derivative and we find the slope. We put it in point slope form, and then we set y equal to 0. This will give us the x-intercept of the tangent line, and we're going to use that to approximate the x-intercept of the actual curve. Thanks.